All right, let's go ahead and get started. Everybody having a good time so far? Yeah. Woo, yeah. All right, I'm Sterling. I work for ZipRecruiter. That's all you ever need to know about me. Actually, this whole talk is about me, so this is going to be great. This talk was originally titled something else. If you look outside, it probably says something else on the paper out there. I started writing that talk, and I got bored. And I thought, if I'm bored writing the talk, you guys are going to fall asleep. So let's not do that talk. So instead, I'm going to do OFUN and Perl 6, which is going to cover that stuff too, but just more briefly. So who knows what OFUN is? Chaz.
Optimized for fun.
That's right, optimized for fun. So it's about things I love. So somebody gave a talk years and years and years ago. I'm really old. Not as old as Chaz. Where somebody mentioned OFUN, and I just call all my hobbies OFUN now, especially because there's a lot of people I say that this is an OFUN project, and they look at me like, what does that even mean? And then I don't explain. So it's about things I love. One of those things is Perl 6. I really like Perl 6. I think Perl 6 is imperfect, but such is life. But all of my OFUN projects seem to involve it in one sense or another, at least insofar as they involve programming. If you ever want me to talk your ear off, ask me about 3D printing. Because I really like 3D printing. I started doing that before this conference last year in Salt Lake City. Actually, I used this conference as my excuse for buying the 3D printer. Can I get this closer to me? I feel like it's really like, there. Is that better? Yeah, that's much better. Okay, so, it's a little boomy still. So 3D printing is a thing I really like a lot. I have a Prusa i3 Mark III's MMU 2S, so I can tell you what all that means after class. I also have gotten recently into homemade electronics. I got into computer science because I hate hardware. All the physical, like hardware bits in reality are problematic. They don't, like, electricity is stupid. It works in the dumbest ways, and I don't understand it. It's like, the stuff inside my computer contains magic smoke, and as long as I don't let it out, it works. However, that was my old line. My new line is, actually, hardware's getting kind of fun. I don't know if you've messed with hardware in the last 5 or so years, but now you can buy stuff from like SparkFun and Adafruit and random people on eBay that are in China, and you can get like modules that are pre-built, and you just sort of like run wires between them and they do things. And you don't have to worry about letting out the magic smoke because they've put all the right diodes and resistors in there, unless they're from China, and then maybe you have to be more careful. But even for the stuff from China is pretty good these days. So I've gotten into this. This is really fun, and I'm going to show off some of those electronics you might have noticed. I also love children, maybe not your children, and I like books, especially reading books to children, and I'm going to talk about that too. And I'm really weird, just so you know. So I gave this talk last year, and I really like the fact that when the video of my talk went up, that this book got put up as the thumbnail, even though it's like midway through the talk and it's a short slide. And I didn't have this book with me because I couldn't find it. This year I actually saw this book sitting out about 2 weeks ago, and I grabbed it and hid it in my room because I knew it would disappear again because my 4-year-old likes this book a lot. So if he knew I took it, he'd be angry. In fact, he was angry that I took some of these things for the electronics I brought. So the reason I put that slide up is because I'm going to give you the report of, so I just gave you like the general overview of things I love. Now I'm going to give you the specific things I loved this year. I'm sure you're excited. So 3D printing. Mega Man. That's a big Mega Man, by the way. That model took, it's designed by a YouTuber who goes by Chaos Cortec. I assume that's not his real name. It's pretty big. It took 130 hours to print. It came in 20-some parts. It's in 5 different colors. Everything below the head is glued together. Actually, it's not glued together right now because there was an accident involving my hand reaching for a light switch, and I need to fix that. So he's kind of in bits right now. And then everything from the head up is pressure fit, so it was kind of fun taking a mallet and hammering his eyes in. This actually represents, so of those 5 colors, I used almost an entire spool of that dark blue color. And if you know anything about filament, that's a lot of plastic. Like, I print all sorts of stuff all the time, and it seems like I never go through filament, but I went through entire spools. So this Mega Man weighs like, I don't know, 7 pounds. It's like 4 kilograms of filament. It's pretty fun. I also upgraded my printer, so there's my Mark IIS with an enclosure, and it has pretty lights on it. Unfortunately, I can't use the enclosure right now because of something else that happened. But the remainder of those lights, I put in my wife's kitchen, so my wife's happy. I'm trying to figure this thing out. I got a Christmas tree from Home Depot, and it has this fascinating set of lights that change colors, like they're like neopixels, except they have only 2 lines. So those 2 lines coming out are the only 2 lines going to that. And if you know anything about electronics, that means it's sending data and power over the same lines somehow, and I'm still trying to figure that out. And if I figure it out, I'm going to like design my own custom controller and put it on my tree. We don't talk about this. My son started Taekwondo, which is pretty cool. He's probably getting his orange belt soon. The reason I can't use the enclosure is because of this upgrade. So now I have this big thing that sits on top of my printer. You can see some of the parts that came, and I had to put it all together, and that was really fun. Well, it was fun for about the first 10 hours, and then I spent the next 20 hours fiddling with it, trying to get everything adjusted just right, and I was about to chuck it out the window. But it all came out all right, and the end is I can print in multiple colors now. So with printing, 3D printing, if you know anything about it, you can print 1 color per layer, but having multiple colors in a layer is complicated. Which enabled me to build this, which I also have up here, which ties into this as well. And then when I go home, one of the things I'm going to do is start messing with this big box of, you can't really see it, this picture was taken by my son yesterday. So these are bits and pieces of robots that I'm going to be building with my 3 sons. We're going to assemble some robots to do, they wanted to do laser tag robots. And I'm not going to let them do it remote control. They have to program it for real. We went to go see these, so this is like an aside. So we went to Silver Dollar City, as one does, and we went to a show called the Phoenix Fire Dancers. And it was really a cool show. For most of the show, well, the last half of the show, they're dancing with fire, which is why they're called the Phoenix Fire Dancers. But for the first part of the show, they had like big like bow staffs and nunchucks and all sorts of stuff they were dancing with that were all lit up by flashing LEDs that made all kinds of cool patterns, and it was amazing. So now I'm like, I need to do something with this. So that's a future project I'll probably come up with. And then that was my eldest son. With he uses my printer more than I do now. And then this, I was actually telling Chaz about this before just before my talk. So for about $2, you can get 3 of these little modules, and this module is kind of cool in that well, first you have to solder it all together yourself. So it's soldering practice for me because my soldering is really, really awful. But that actually doesn't look too bad. But those 2 wires on the end, this is basically a thing that boosts the voltage up to a level where you can arc electricity across the 2 ends of those wires at the end there. And with 5 volts, you can catch things on fire. So if you put a radio transmitter on that with a battery, on 4th of July, I think a radio receiver and a battery, I think there can be fun. Especially if it involves a button you're not supposed to push. All right, so this is the don't push a button button, and unfortunately, it has not traveled well. It's got like 3 different bad connections inside. But I'm gonna pass this around. You all are supposed to don't push the button. It says it all right here on it. Chaz, would you like, please be gentle with it. It's like I said, it didn't travel well.
Did you fly here with all that stuff?
Yes.
TSA loved you?
So the excuse for buying the 3D printer was I was going to make a name tag last year, which I did. I did not want to have open electronics because that seemed like an error for the TSA. I joke about taking the electronics with the wires hanging out and then some blobs of clay with me just to see what TSA does, but I'm not really that brave. Maybe if I was single, I would do that, but no.
Try to press the button. The TSA try to press the button.
So the TSA asks you to take all electronics larger than a cell phone out. I kind of didn't tell them about it.
That's not harder than a cell phone because the electronics is about...
Well, see, I would have just said, well, when I was a kid, a cell phone was about that big, so. So the button is part of the talk. The button is got a ESP8266 chip inside, and it's kind of running Perl 6. The hat is also kind of, actually the button's not running Perl 6. The hat's kind of running Perl 6, I should say. So this is a hat. It's really heavy, so I was putting it on the podium because the backing plate here is metal ties, and I've got 4 nickel metal hydride batteries in a pack up here, and it's really heavy. And I figured it would fall off my head if I'm talking and not paying attention. So it's sort of running Perl 6. So here is one of the Perl 6 programs it could be running. It's not actually running this one because this one's, I picked one that was short, which isn't actually one that's running. Although I could have picked one that is running on there now because I added some that are about this short. So this is Perl 6. See, it's got use v6 at the top. And then this is all Perl 6 syntax. Why didn't that slide get the correct font? Oh well. Yeah, it's Perl 6, see? It's running Perl 6. It's Perl 6, but it's, if you know Strongbad, this is the virus email. It's being eaten by some Linux or something. It's like the ugliest, most hideous Perl 6 ever. And it's not actually running that Perl 6. So what it's actually running is this. Now, if you don't know anything about Perl 6, you're going to be like, how in the heck? I did not see anything that does this. Okay, well you did, but you didn't know you did. And the way it works is this. So program up there is not a Perl 6 built-in of any kind. It's just a subroutine. And that subroutine takes a code reference, and in Perl 6, every block is a code reference. So every block is a magic code reference, and some of them are pointy blocks. So if you look down there by loop, there's a pointy block, and in a pointy block, it's like a subroutine with arguments. And that's like if you know anything about for loops in Perl 6, the for loops are actually receiving a pointy block as well, or you could put it a regular block if you want. And then the other thing is that $_ in Perl 6 is used slightly differently than it is in Perl 5. So in Perl 5, $_ has this problem where you can do whatever you want. You can hold on to it if you want to. Yeah, just don't push the button. So $_ has a slightly different use in Perl 6. Perl 5, problem. Which functions use the $_ variable that's implied? Like, if you call a function and you don't give it an argument, it will use the $_ but it's unclear which ones use it. In Perl 6, it's clear which ones use it because you just use this dot notation, which basically says, I'm calling a method on $_ if I don't specify anything before the dot. So, and dot replaced the arrow operator in Perl 5, if you're not aware of that. If you've been under a rock for the past several years. Perl 6 is totally released. So what happens is inside of that, so that program method, or I'm sorry, the program subroutine at top gets that code reference. Before it calls the code reference, it makes the program builder object $_. And so every one of those dots is calling a method on program builder. Program builder is a code generator. So if you look through here, it has this self.ops. I'm not actually explaining any of this in detail. I can go into it in detail afterwards if you want to. There's just not enough time to go through it all. But this ops thing basically is pushing operations onto the code and the code that's being generated. So op sub is an operation, op return is an operation, op pop here is an operation, op halt, of course, is an operation, op return, op go sub. This is all integers that make up bytecode. Like this. So here are a bunch of the operations. So of course, op halt is dead. And then we have a bunch of others, op eq for the equal operation, and it's kind of an RPN thing. So you push things onto a stack, and then this pops operations off and runs them because that's easy. And here's the start of the actual VM. The actual VM's like pages and pages long, and I'm not putting it on slides. And then here's where some of the execution of the operations happen in the VM. You'll notice that this is no longer Perl 6. So I do a lot of C++ too. I'm not especially a fan of C++, but it turns out that it's kind of handy to know if you're going to do embedded programming right now. I would love to learn how to run Perl 6 on an ESP. I don't know. I can't even imagine how you would even run it on an Arduino with the memory footprint available to you there. But I think on something like an ESP, it might even be possible somehow. I'd like to figure that out at some point. Okay. So this is the program. And then I do something to run it, and then something to get it onto the thing to run. Well, I mentioned that I'm using ESP, so the button is an ESP8266 chip. The ESP8266 chip is a Wi-Fi enabled microcontroller made by Espressif, a Chinese company. This one is using the development version of the next version of that chip, which is called the ESP32, which is kind of in pre-release, but it's really easy to get as a hobbyist. So it runs it's similar, but it also has a bunch of other features like a Bluetooth capability built in and some other things. But there's no, how did I get the program on there? Well, obviously I used a web service. So here's a crow. Anybody know what crow is? Anybody written a crow service? Woo, crow's cool. So I wrote this service in Crow last year, and it's not a very good example of one, but it is an example of one. And Crow is a way of doing asynchronous web programming, which is what my talk was originally about. And we were going to talk all about this stuff, and I was getting bored. So just to explain what's happening here, it has kind of a dancer-style interface to it. At least it feels like Dancer to me, as somebody who's never actually used Dancer. So you declare this route. So again, route here, up there. I'm pointing, and I can see what I'm pointing at, but you guys can't see what I'm pointing at. Route here is a function that takes a code ref, and it does a bunch of magic to consume all of these things like post here. And so post says, I'm going to create a new path that takes post requests. And then you pass it, remember I mentioned pointy blocks? You pass it these pointy blocks that tell it what the path should be. And so they actually use the signature of the functions that take the arguments as the way of defining the path, which is kind of nifty and kind of magical too. But because the way Perl handles multi-dispatch, that ends up working pretty well. Is that really enough of that? I can't remember where I am in my slides now. Oh yeah. I also want to talk about my toddler clock. I'm only halfway through? Holy cow. This may end early, guys. So that's my toddler, except clearly he's not a toddler anymore. He's also like 160th percentile on weight and height. So that's 160th percentile if you know math. That's not a thing. That was supposed to be a joke. So it's actually a preschooler clock now. So do you guys know what a toddler clock is? Do any of you have young children? So what's one thing a young child does when they're sleeping? They don't sleep. Sleeping like a baby is the biggest joke ever. I have never met a baby that sleeps like a baby. Certainly not my children. Like, we have friends that are like, oh, he just sleeps all the time. We go for a ride to the Walmart and he just falls asleep. No, my children never ever fall asleep, ever. And it makes us a little crazy. Like, we're just a little crazy for sleep. So I said one day to my wife, I just want a clock that turns like green when they're allowed to wake up, and they can look at the clock and it's yellow or some other color, they're not allowed to get up. Well, it turns out such a thing actually exists. And if you attended my talk last year, you heard the story about why buying one of those might be a bad idea, which involves my middle son, who was the one pictured in the center of that picture of Taekwondo. He when he was about this, well, he wasn't this size when he was this age. When he was about 4, he was still using the toddler clock. It was in his room, and about 3 in the morning, I wake up to him screaming like someone has stabbed him. And we go in there, and he's screaming, and the toddler clock is going beep, 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 beep. Someone decided to put a beeper on there. A beeper on there for low battery indicator. So that clock went into the trash that day and was never seen again. Actually, it's not true. We kept it for a long time, and then we threw it away. So I decided when we had a third child that even though that hadn't actually gone to the trash yet, I was not putting that in his room. Because I can't be trusted to change batteries. And besides, changing batteries is so wasteful. Why would you change them early? And why would you put a beeper on it? That's ridiculous. Anyway, so I made another clock that my clock uses basically almost the exact same software that runs this thing, because I'm too lazy to be bothered with writing more software when I've already written something that kind of does what I need already. And it's blue during the day, and it's yellow at night. He's outgrowing it. He's like 4 now. He can totally read clocks now. We could tell him at any time, here's a regular clock in your room, and you're allowed to get up after the big number says 7, not sooner. The one thing I can say for my children is that they refuse to get out of bed unless they've been allowed out of bed, and it's not like I've ever punished them for getting out of bed early. They're just like, they beg me to come in to let them out of bed, and I'm like, okay. So we're gonna make this into a toy. Oh wait, I already did. So I've turned the sound off because you wouldn't be able to hear it anyway. But so here is the Toddler Clock. That's that thing on the thing that's flashing there. And you can see, oh look, it's the don't push a button button. And he thinks it's hilarious that he gets to push the don't push a button button. Oh, I did turn on, oh, there's the sound. You can barely hear it. Anyway, I can't turn the sound down. That's amazing. So, as you can see, it's flashing. That is a very, what we would call an MVP edition of this solution. At work, we would call that a minimum viable product. So flashing was the easiest way to make it do something weird. What I wanted to do is more stuff. So if you'll indulge me, I'm going to read this book. Not all of it, just parts of it. So this book is by Bill Cotter. I highly recommend it if you have young children, first grade or younger. It's really fun. If you have older children, they will also like it. They just will pretend they don't like it. So, hi, my name is Larry. Welcome to my book. There's only one rule. Don't push the button. Seriously, don't even think about it. It does look pretty nice, though. I wonder what would happen if we pushed it. And this is a part where, as a parent, you feel sad because your child is getting older. Because my son used to do this thing. He'd read this part, or he would, after I did it a few times, he would always insist on saying it himself, and he'd say, "No, we can't, we mustn't," and he would do the arm action and everything. It was great. Psst, no one is looking. You should give the button one little push. And then, of course, now I'm yellow, push it again. And it gets worse. I won't spoil the end. But in order for me to fully make the don't push the button work to the best extent possible, it will have to have an accelerometer in it. This book is great. And I want to make this do some of the interesting things. So we'll have to turn the light, we'll have to turn like some sort of greenish, garish yellow, really bright, and then maybe have it flash green and purple, and then all sorts of colors, and each time it gets a little worse. This progression also makes me want to build one of those. Have you guys seen those awesome boxes where you flip the switch and like the cat or whatever reaches out and switches it and closes the box? I really want to make one of those. There's so many fun things to make in the world. No, I already did that. Hello? No, I already did that. Move to the next slide. Okay, so I guess this leads me into, how much time we have left? 10 minutes. Okay, so going on to my original topic, so I'm going to start boring you now. About 5 years ago, I created this thing called the Web API for Perl 6, and I had this idea that I would spearhead the move towards a PSGI type thing for Perl 6. And I'm really bad at community. Like, I'm really like horrible at it because I just want to spend time with my kids. And so I don't spend a lot of time in chat rooms or on email lists and stuff like that. So if someone is interested in helping spearhead this and taking it forward, I think there is a demand. There's there's basically one implementation of something like it called Crust, and I have never touched it. I've never looked at it. I've never messed with it. Is anybody who works on Crust here? I didn't think so. Anyway, I have a thing called I have a thing called SMAC, which is supposed to be the reference implementation of this, and Crust is kind of like the reference implementation of Perl 5 PSGI and Perl 6, which, if you know anything about PSGI, it's great. I mean, I want to say that it's bad, but it's dated. PSGI was built in a time where HTTP 1.1 was state of the art. Before WebSockets, before HTTP 2, before HTTP 3. And we now live in a universe where just synchronously taking a request and sending a response is no longer what the web is about. It's more complicated than that. It's still what technically happens, but it's more complicated than that. It's much more nuanced. And so one of the things I was I started just trying to translate PSGI into Perl 6, and then a bunch of people said, don't do that, that's dumb. Web has moved on since then. And then I started doing research, and I'm like, yeah, you're right, it has moved on. And so part of the issue is that it's much more asynchronous now, the way we think about web programming. And Perl 6 has this amazing thing built in called asynchronous programming. It has all sorts of support tools for it. And so I use those. So as an example, this protocol has built into it the use of supplies and the use of promises. But all of those things are built in such a way that you could use synchronous tools and upgrade towards that. So if you provide, in Perl 6, if you provide a list, you can coerce a list into a supply, which is the asynchronous version of that. So if you don't know, a supply is it's like a stream of promises where I'm going to deliver items to you out of this list whenever they come. Whereas a list is, we wait until we get the whole thing and then we deliver throw all of them at you at once. So anyway, but if you have a list, you can seamlessly upgrade it. So if you have all the items at once, you can deliver them as a supply, and that can happen more or less automatically. And this tries to take advantage of that. And I think I've done a good job of it. But the reason that this has been a 0.7 point draft since, I don't know, 2016 is because I really haven't had a lot of time to mess with it. So if anyone is interested in web programming and learning about HTTP 2 and maybe even trying to implement it, which is actually really interesting. Like, if you don't know anything about HTTP 2, you should read about it, because it's a really interesting, I don't know, maybe I'm just a nerd and I like it. But it's a really interesting change in the way of thinking about HTTP 1. And I've started reading about HTTP 3, and that one kind of breaks my brain. But it's basically, from what I can tell, HTTP 2, except now it's running over UDP, sort of. Well, it's actually running over UDP, but it's more complicated than that, too. This is probably my most popular module on the Perl 6 modules list, or the Perl 6 ecosystem, as it used to be called. I don't know what to call the Perl 6 module system anymore. We don't have a CPAN. We have modules.perl6.org. It's kind of CPAN. But DOM Tiny is cool. I would love to talk about that more with you guys. It's basically, are you guys familiar with DOM Tiny in Perl 5? No? Are you familiar with, was it Mojo? What is that thing called? DOM Tiny was its old name. It has a new name now. and it has something to do with Mojo. But it's basically a really cool little parser for HTML or XML. Then I have this new project I'm working on called Cofra, which is a common objects framework, which is basically like all the things I hate repeating myself in Perl 6 thrown into an application framework. It's kind of like a mixture of an inversion of control and web application framework put together. Also, there's some things about Crow that I find irritating, like how similar it is to Dancer, which I don't like. There's a reason I haven't used it. But I don't like Catalyst either, so I don't like anything. I'm an engineer. Okay, that's kind of the end of my talk. I would like to say thanks to my employer, ZipRecruiter, for sending me here. They are a really great place to work, so if you are looking for a job, we are always hiring. Yeah, I've worked there for like 4 years now, which is a long time. And yeah, I really enjoy working there. Chaz works there, and Chad works there, and Vol works there. You can talk to any of us. Who else? What? Oh, Ben. Ben's here. Ben's even a manager. Even. Well, Ben was hired after me, like a whole week and a half or something. But now he's a manager. Any questions? Ask me about 3D printing. Yeah.
Was that box of 4-color print?
The box, yes, I did forget to mention, I was going to say. So the box is a 4-color print. It's got silver, yellow. Okay, here's how nerdy I am. I could probably tell you the brands of each one of those filaments. And they're like random weird names. So yeah, it's 4 colors. It was printed all at once: silver, black, yellow, and white. The white, never buy that. I don't like the white on there, but the rest of the colors are fine. So yeah, that was a 4-color print. It was printed on the face with the lid at the same time. I think that print was 20 hours. So the thing about 3D printing something of that size, if it was a single color, it would probably take, I don't know, 4 or 5 hours, I would guess. But in multicolor, because the printer basically has one set of motors that are moving the head around and extruding the plastic that it's melting onto the plate. It has another set of motors that load and unload filament. So what happens is it does all of the yellow for a layer, and then the head stops, and then it pulls the yellow out, puts the black in, and then it goes and it has to purge the yellow that it just had in it from the head, because otherwise the colors would mix in really ugly ways. And so it prints on a little, it builds up a separate block of purge, so you waste some plastic this way. And then it prints some more, and then it does it again. So that takes, that usually quadruples the time in my experience. So.
Is there any such thing as like a 4-extruder head, or you just have all the colors?
So the question is there anything such thing as a 4-extruder head? Yes. There are actually several different ways of doing that I've seen. And this is all, I'm just talking about FDM printing, where you've got a spool of plastic that you're feeding in, it melts the plastic and lays it down layer by layer. There are different printing technologies, that's just one of them. But yes, if you're doing that, one possible solution is you can have either multiple heads, so you have 2 heads are pretty common. 4 heads I have not seen very often, but I do think they exist. There you have problems where the thing about 3D printing is you need micron level alignment of the head up and down. And then when you have 2 heads, you have to get both of them aligned perfectly to like almost, I don't know if it's submicron, but it's like super fine alignment. And that's really hard. So you do see that some. Mine changes. Another solution is you can, there's a product called Mosaic, which fuses, see, I'm going to talk forever, which fuses filament together as it goes, so it like has a splicer inside and its own hot end, and it fuses them together ahead, and then you just have to have like special software to make sure to synchronize the changes. so that they're about right, and you don't like slide off and go off into La La Land and end up with weird colors. There's also tool changers where the head is modular and it picks up the head, moves it to a side, and dumps whatever head it's got on, and then pops on a new head. And that new head has each of the heads have the filament attached to them directly. Yeah, like that. The problem, and then that, I mean, each of these have their own trade-offs. Like engineering is all trade-offs, of course, right? And so the trade-off on that one is that you have to make sure that whatever does the latching doesn't throw off that like micron level alignment on each grab. So there has to be some like metal on metal kind of thing to make sure that it stays aligned. Or you can just accept the fact that you're going to have sloppy prints, which also is fine on some prints. Like this one, I wouldn't want to have sloppy on the color changes. But like if I was printing like sculptures with like of dogs or something, I probably wouldn't care. And there's another one that I've seen at least one company working on mixing filaments. So they have a 4-color head and they mix the filaments inside. I don't know how that would work. I'm trying to imagine how you would get 4 different pigments to mix inside of the melt chamber of a hot end, and I can't. I mean, the hot end on a 3D printer is a glorified glue gun. So anyway. Thanks.